In the following two examples, we're going to try to factor quadratic expressions where a is not equal to 1. In our first example, we have a is equal to 3. So a is not 1, and it's not going to be quite as easy for us to factor this quadratic expression. So what I tend to do is I tend to list my value of a and c. So in our case, we have 3 and 5. And what I want to do is list all factor pairs of both the numbers 3 and 5. So in this case, 3 can be written as a product of 1 times 3, and 5 can be written as a product of 1 times 5. These are the only possible pairs of factors we have for 3 and 5. What I do next is I take one of my lists, whichever one is shorter, and I flip the order of the numbers. And the reason for doing this is to capture all the different possibilities of our inner number. So I'm going to flip my second list. And by flip, I mean I'm going to take each pair and just rewrite the numbers in a different order. So sometimes it might be adding 1 or 2 or 3 or even more expressions to this list, but you only have to flip one of your lists. Now the true reason for writing these lists is it tells us how to factor the first and the last term of our quadratic expression. So I know that 3x squared can be factored as 1x times 3x. And I know that 5 could be factored as 1 times 5 or 5 times 1. So this implies that when we go to factor our quadratic expression, x and 3x are going to be the first two terms of our two binomial factors. However, we're unsure as to whether or not the second two terms in our binomial factors are going to be 1 and 5, or if the order is going to be 5 and 1. So what I'll do is I'll take my first pair, which is 1 and 5, and I'm going to put them in here for now, and I'm going to see if the last two terms, as well as our two inner terms, multiply together to give us the middle term of 16x. Notice that our two outer terms in the binomial factor, x and 5, are going to give us 5x, and then the middle two terms, 1 and 3x, are going to give us 3x. The sum or difference of these two terms is going to give us 8s or 2s, which is not 16. So that means that 1 and 5 mustn't be the pair that we need. Now let's try 5 and 1. Our two outer terms give us 1x, and our two inner terms give us 15x. However, we need negative 16. That means that both the 5 and the 1 must be a negative number in order to get negative 16. And we can double check by doing a quick multiplication inside of our heads. X and 3x give us 3x squared, negative 5 and negative 1 give us positive 5, and then our two outside terms and our two inside terms, when multiplied and added, do give us the negative 16x. Next, let's factor the quadratic expression 6x squared plus 11x minus 21. I'm going to begin by listing a and c. Notice I'm only considering positive numbers here. I'll worry about the signs when we go and factor later. So let's find all of the different factor pairs for 6 and 21. For 6, we have 1 and 6, 2 and 3. For 21, we have 1 and 21, and 3 and 7. Now, like before, I'm going to take one of these lists, I'm going to choose the second one, and I'm going to rewrite them in the opposite order. So I'm going to write down 7 and 3, as well as 21 and 1. Unlike our last example, I'm not really sure which factor pair to choose for 6x squared. I could either choose x and 6x, or 2x and 3x. So for now, I'm going to put x and 6x in, and then I'm going to try to test some possibilities for 21, and to see if I can get my middle term of 11x. Let's begin with 1 and 21. If I multiply the two outside terms, I get 21x, the two inside terms give me 6, and this isn't going to get us to 11. So it can't be 1 and 21 that we need. So I'm going to move on to the next pair, which is 3 and 7. The two outside terms give us 7x, and the two inside terms give us 18x. Notice, if we put a plus sign in front of our 18x and a minus sign in front of our 7x, that difference is going to give us 11. So these are the possible factor pairs that we need. I'm just going to circle them in red. 1 and 6, and 3 and 7. So adding a plus sign in front of our 18x and a negative sign in front of our 7x, we can double check and make sure that our answer is correct. Our first two terms when multiplied give us 6x squared. Our last two terms when multiplied give us negative 21, and we know that our two inside terms give us 18x, and our two outside terms we subtract off 7x to get our middle term of 11x.